So now we have that theta is 180 degrees. That's going to be this straight angle right here. So the point associated with, a theta of 180 degrees is when x is -1, y is 0. Sine of theta, so 180 degrees, is y, which in this case is 0. Cosine of theta, which is x, and I keep repeating this even though I don't really need to because we need to learn these. Cosine of theta is x, which is -1. Tangent of theta is y over x, which is 0 over -1, which is 0. Cosecant of theta is 1 over y, which is 1 over 0, so that's undefined. Secant of theta is 1 over x, which is 1 over -1, so -1. And cotangent is theta is x over y, which is -1 over 0, which would also be undefined. So we found that for a theta of 180 degrees, or pi, cosecant and cotangent are undefined. Last but not least, let's take a look at 270 degrees. So here's a arc length associated with a theta of 270 degrees, right? It's right here. This is 270 degrees. That's when x is 0, y is -1. Sorry, I kind of covered it up. Label our x and y. Sine of theta is y, which is -1. Cosine of theta is x, which is 0. Tangent of theta is y over x, so -1 over 0, so that's going to be undefined. So tangent is undefined for an angle of 270 degrees. Then I have cosecant, which is 1 over y, which is 1 over -1, which is -1. Secant, which is 1 over x, which is 1 over 0, so secant's undefined. And then cotangent is x over y, which is 0 over -1, which is defined, but it's just 0. So here are the values for when we have a theta of 270 degrees or 3 pi over 2 radians. They're equivalent. And we organized all the places where they're not defined into this nice little table so you can take a peek. So let's find the exact value for sine and cosine. So if I have sine of 3 pi, right, that's going to be 180 degrees 3 times, right? So I've got 1 pi, 180 degrees. 2 pi, another 180, 3 pi, another 180. So this is the point where I would end up. So I want to find sine. Well, I know sine is my y value. So sine of 3 pi would be 0. Let's switch colors and I'll look at cosine of -270 degrees. Remember, we always go counterclockwise. So if I have a negative degree, I'm going to go clockwise. I've got -90, -180, -270, right? This would be -270 degrees, x and y. Cosine is x, so I have a cosine of 0 for -270 degrees. So how do we find the exact value of trigonometric functions? Well, for 45 degrees, we're going to use the 45-degree special triangle, right? We've had this special triangle we saw in geometry with side lengths x and hypotenuse y. Well, and hypotenuse x square root of 2. Well, I have to set this equal to 1 and solve, right? That's going to give me 2 square root of 2 over 2 for each of my side lengths. So this point on the circle would be the square root of 2 square root over 2 square root of 2 over 2. That's going to be one of the 3 points we really need to learn on our circle. So now that we have our point on our unit circle, I want to find the 6 trigonometric functions of pi over 4. So sine of theta, which is 45 degrees or pi over 4, is going to be the square root of 2 over 2. Cosine of theta, which is x, is going to be the square root of 2 over 2. Tangent of theta, which is y over x, is going to be the square root of 2 over 2 over the square root of 2 over 2, which is 1. Cosecant of theta, which is 1 over y, is 1 over 2 square root of 2. Sorry, square root of 2 over 2, which would give me 2 over the square root of 2. But we don't like radicals. That equals 2, that equals 2. I get square root of 2. For secant of theta, which is 1 over x, I'm going to get the same thing. And then for cotangent, I never leave myself enough room, do I? Cotangent of theta, that's going to be square root of 2 over 2 over the square root of 2 over 2, which again is just 1. So those are our standard values for when pi over 4 is 45 degrees, is our theta. So let's go over some examples where we can find the exact value of trigonometric expressions. I know that at 45 degrees, which is pi over 4, I have the point square root of 2 over 2. That's one of the key points we need to learn and remember on our unit circle. So if I have the cosine of 45 degrees, remember cosine is x, so that's going to be square root of 2 over 2. If I have a sine of 270 degrees, well, 270 degrees, that's all of this goodness right here, right? This is 270 degrees. And if I want to know sine, that's my y value, so that's going to be negative 1. So my answer would be negative square root of 2 over 2. If I want the cotangent of pi over 4 minus the cosine of 270, well, the cotangent of pi over 4, remember cotangent is x over y. Since my x and y are the same, that gives me 1. Minus the cosine of 3 pi over 2. 3 pi over 2 is 270 degrees. My cosine here is my x value, which is 0. So I get 1. Next, I have the cosecant of pi over 4 squared, which was square root of 2 squared, minus my secant of pi. Well, here's 180 degrees. Secant is 1 over x. X is negative 1, so I've got minus a negative 1. So I have 2 minus a negative 1, which is 3. So that's where we find the exact value of trigonometric expressions.